In section 7.6, we're going to be exploring the next two trigonometric ratios, which are the sine and cosine ratios. So to start, let's actually define what those ratios are. So once again, it says let triangle ABC be a right triangle. So again, we're only using right triangles with an acute angle A. The sine of A and the cosine of A, written as sin and cos, we do not pronounce that as sin and cos. When you see this, you say sine of A, cosine of A, are defined as follows. So the sine of A is the length of the opposite leg over the hypotenuse. I usually write it as this. The sine of A is equal to opposite over hypotenuse. The cosine of A is the length of the adjacent leg to angle A over the hypotenuse. So again, I write it like this. Cosine of A is adjacent over hypotenuse. So remember, tangent is opposite over adjacent. So you may have heard something that other math students have talked about, and it's something called SOHCAHTOA. And it's spelled like this. So the S stands for sine, and it is opposite over hypotenuse. The C stands for cosine, and it's adjacent over hypotenuse. And the tangent is the T, and it is opposite over adjacent. So SOHCAHTOA is a mnemonic device that you can use in order to remember sine, cosine, and tangent ratios. So again, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So once again, referring back up here, if I was trying to find the sine of A, I would go opposite over hypotenuse. If I was trying to find the cosine of A, I would go adjacent over hypotenuse. And if I was trying to find the tangent of A, opposite over adjacent. So let's move into example number 1. It says find the sine of A and the sine of B. Again, do not read that as sin. So sine of A, we would start with this angle here. The side opposite A is 40 and the hypotenuse is 85. So the sine of A, remember, is opposite over hypotenuse, so 40 over 85. And you just want to make sure you put that in lowest terms. So that would be 8 over 17. Now when I find the sine of B, I'm going to go off of this angle here. And again, it's still going to be opposite over hypotenuse. So in this case, the opposite side is 75 and the hypotenuse is still 85. So to put that in lowest terms, I would get 15 over 17. So what this really means, just like before when we were talking about tangent, that every angle that has a measure of whatever angle A is would have the same ratio of sides. So this would be 8 over 17. So whatever angle A is, that ratio is 8 over 17 for no matter how big or how small the triangles are, because remember, we're basing these off of similar triangles. And the same goes for angle B. Whatever this angle measure is, when I take the opposite over hypotenuse, I'm always going to get 75 over 85, which simplifies to 15 over 17. Every triangle, no matter how big or how small, that has this angle measure for the sine would always get 15 over 17. Because again, we're basing it off of similar triangles. So now let's move into example number 2. Find the cosine of P and the cosine of R. Again, do not read that as cos P, cos R. It's cosine of P, cosine of R. So we're given all three sides. So cosine of P, we're going to start here at P. Cosine is adjacent over hypotenuse. So if I'm doing the cosine of P, I'm going to take the adjacent side, the side that's touching it, 5 square root of 5, over the hypotenuse, which is 15. So just to reduce that, I would just reduce the 5 and the 15, which would be 1/3. So it'd end up giving me square root of 5 on top, 3 on the bottom. For the cosine of R, I'm still going to do adjacent over hypotenuse. This time, the adjacent side to angle R here is 10. Hypotenuse is still 15. So I would have 10 over 15, which in lowest terms is 2/3. So just like we talked about before, any angle that is equivalent to angle P would have this as the ratio of the adjacent side over the hypotenuse, no matter how big or how small, because again, we're basing these off of similar triangles. Same thing goes with angle R. Whatever this angle measure is, the adjacent over the hypotenuse will always be equivalent to 2/3, no matter how big or how small the triangle is, because we're basing it off of similar triangles. Now on to just some terminology. If you read angle of elevation, what this means is if you look up at an object, then the angle your line of sight makes with the horizontal line is your angle of elevation. For the angle of depression, if you look down at an object, the angle your line of sight makes with the horizontal line is the angle of depression. You'll see this, it'll make more sense in the coming problems. So here's example number 3. A rope staked 20 feet from the base of the building, so that's what this is right here, goes to the roof and forms an angle of 58 degrees. So since I'm going up, that'd be my angle of elevation. So an angle of 58 degrees with the ground. To the nearest tenth of a foot, so 1 decimal place, how long is the rope? So I'm given this 58 degree angle, and I'm looking for how long the rope is. So I'm going to have to figure out what trigonometric ratio am I going to use in order to solve this. So what I'm given here is the 58 degrees. I'm given the side that is adjacent to the 58 degrees, and I'm looking for the hypotenuse. So adjacent over hypotenuse is the cosine. So I'm going to say the cosine of 58 degrees is equal to 20 over x. So again, remember that this is just a number. Every angle of 58 degrees has the same ratio of the adjacent side over the hypotenuse. So I'm going to use this number in order to solve for x. So first thing I need to do is get the x out of the denominator. So I'm going to multiply by x. So I'd have x times the cosine of 58 degrees equals 20. And then again, remember, this is just a number. So I'm going to divide by cosine of 58 degrees on both sides. So my final answer would be x equals 20 over the cosine of 58 degrees. This would be my exact answer, but remember it told me to round to the nearest tenth of a foot. So in my calculator, I'm going to take 20 divided by, hit the cosine key, 58 degrees. And I get about 37.7 feet. So the length of that rope, using the 58 degree angle and the fact that it was 20 feet from the base of the building, this rope would be about 37.7 feet long. And now looking at example number 4, a pilot is looking at an airport from her plane. The angle of depression, because we're looking up here in the plane and down to the airport, so it's an angle of depression, is 29 degrees. Because this angle right here would be 29 degrees if I draw this horizontal line outward. So this angle is 29, so just doing alternate interior angles means that this angle would also be 29 degrees. If the plane is at an altitude of 10,000 feet, approximately how far is it from the airport? So the plane is 10,000 feet above, and I want to know from the plane to the airport, what is that distance? So we're given this 29 degree angle. I'm given the side that is opposite it, and I'm looking for the hypotenuse. So opposite over hypotenuse is sine. So I'm going to set this up and say sine of 29 degrees is equal to 10,000 over x. So remember, again, just like before, this is a number. Every angle of 29 degrees, when you take the opposite side over the hypotenuse, will give me the exact same ratio, the exact same number. So I'm going to use this number to solve for x. So just like before, I got to get x out of the denominator, so I'm going to multiply by x. So I have x times the sine of 29 degrees equals 10,000. Then I would divide by the sine of 29 degrees because that's just a number. So my exact answer would be x is equal to 10,000 divided by the sine of 29 degrees. But this is clearly not how you would answer somebody asking you how far is the airport from the plane. So I'm actually going to just find a decimal approximation. It says approximately, so let's just round to the nearest tenth. So taking 10,000 divided by the sine of 29 degrees in my calculator, I get about 20,626.7 feet from the airplane to the airport. And now on to example number 5. A dog is looking at a squirrel at the top of a tree. So here's the dog, here's the squirrel, and is looking up. So 64 degrees would be your angle of elevation. The distance between the two animals is 55 feet, so that would be this length right here, 55 feet. And the angle of elevation is 64 degrees, just like we talked about before. How high is the squirrel and how far is the dog from the base of the tree? So it's asking how far is the squirrel, so that's the x value here. And then how far is the dog from the base of the tree, so that's the y value. So we're actually going to have to set up 2 problems here. So notice that we are given the hypotenuse. Here's the right angle, so this is the hypotenuse. X is opposite the 64 degrees, and y is adjacent to the 64 degrees. So we're going to be using sine and cosine here. So let's start with x. Again, it is opposite the 64 degrees, so opposite over hypotenuse is the sine. So I'm going to do sine of 64 degrees is x over 55. This is a little bit easier than the last few problems because all I'm going to have to do is multiply by 55 on both sides to get x by itself. So my exact answer would be 55 times the sine of 64 degrees. But of course we want to find an approximate answer to that, so we're going to use our calculators to round this. So typing in 55 times the sine of 64 into my calculator, I get about 49.4 feet. So that is how high the squirrel is up in the tree. And now let's move on to find the y value. That's the distance from the dog to the base of the tree. Using the 64-degree angle, the y is adjacent to that 64-degree angle. So I have adjacent over my given hypotenuse, so I'm going to use cosine. And one thing I want to note here as I'm writing this out is you do not want to use this answer that you got for x because that's an approximate answer. So we want to always go back to the numbers that we were given. We know this is 55 degrees. This was an approximated rounded answer. So we're always going to base everything that we're doing off of the given value, which here is 55. So once again, coming back to the problem, we have cosine of 64 degrees is equal to y, which was our adjacent side, over the 55 hypotenuse. So just like before, I'm going to multiply both sides by 55. So my exact answer would be 55 times the cosine of 64 degrees. But again, of course, we want to get an approximation of that, so I'm going to type it into my calculator and get about 24.1 feet. So the squirrel is about 49.4 feet up in the tree, and the dog is about 24.1 feet away from the base of the tree. And now our last example, number 6, it says use a special right triangle to find the sine and cosine of a 45-degree angle. So if it's saying a 45-degree angle, that means we're going to use a 45, 45, 90. So as always, just like I tell you, always start with drawing a picture. So here is my 45, 45, 90 right triangle. So we want to find the sine and cosine of a 45-degree angle. So let's just work off of this one right here. So just like we've done before in the last set of notes, we can assign arbitrary numbers to the legs and the hypotenuse because we know that when I take a sine or a cosine or even a tangent, it's just referring to a ratio. And as long as that ratio is put into lowest terms, I'm always going to get the same number. So if it's a 45, 45, 90, that means I could just call this leg 1. This other leg would be 1, and we know that the hypotenuse is the leg times the square root of 2. So 1 times the square root of 2 is the square root of 2. So again, if I'm trying to find the sine and cosine of a 45-degree angle, what I'm going to do is take this 45 degrees for the sine of 45 degrees. I'm going to do opposite over hypotenuse. So it'd be 1 over the square root of 2. But as always, you cannot keep a square root in the denominator, so I'm going to multiply by the square root of 2 over the square root of 2. So 1 times the square root of 2 is the square root of 2, and square root of 2 times the square root of 2 is 2. So the sine of 45 degrees, no matter how big or how small your special right triangle is always going to be square root of 2 over 2. When I go to do the cosine of 45 degrees, I'm going to do adjacent over hypotenuse. So again, if I'm working off this angle, the adjacent side is 1, and the hypotenuse is still square root of 2. So just like before, I'm going to have to multiply by the square root of 2 over the square root of 2. There's really no need for doing this since we already figured out what it is up here. So 1 times the square root of 2 is 2, and the square root of 2 times the square root of 2 is 2. So again, anytime you have a 45-degree angle, no matter how big or how small your triangle is, the ratio of the opposite side of the hypotenuse, or the sine, is always going to be the square root of 2 over 2. And the cosine of a 45-degree angle, again, no matter how big or how small the triangle is, anytime you take the adjacent side over the hypotenuse, you're always going to get the square root of 2 over 2. It's all about ratios and similar triangles. So that's it for this section. Make sure you jot down anything you don't understand. Really remember the SOHCAHTOA thing. So if you haven't written it down already in your notes, write it down. SOHCAHTOA, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Write it down, and it'll help you remember all of the trig ratios. So again, write down anything you don't understand that we can cover in class, and we'll see you then.